Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and a very good day to everyone. We are honored to host this event today. My name is Dr. Azri Usman, Dean for School of Leadership, will be the moderator for this webinar sessions. On behalf of the RB Highcom University of Automotive Malaysia, I would like to thank all of you distinguished participants, including captains of industries from all over Malaysia who are with us today. I also would like to wish Ramadan Kareem and stay safe to everyone during this MCO period. Ladies and gentlemen, our speaker for today is DRB Highcom University Adjunct Associate Professor Dr. Imran Sarwar. With more than 15 years of industry experience, Dr. Imran has been working closely with organizations in their journey of embracing digital transformation by structuring end-to-end solutions for Smart City 4.0 and Industry 4.0. For this session, today we'll be covering the following scopes. Firstly, to understand Industry 4.0 ecosystem and its disruptive technology for manufacturing and beyond. Secondly, to access Industry 4.0 ecosystem before, during, and after COVID-19 era in Malaysia and globally. Finally, to highlight the essential skill needed for digital workforce to be aligned with Industry 4.0 requirement for post-COVID-19 paradigm. We will now proceed with the presentation by Dr. Imran. This will be followed by Q&A sessions afterward. For those who may have any questions regarding the topic, kindly please address your question in the live event Q&A section on the right side. Without further ado, please welcome Dr. Imran.
Assalamualaikum. Dr. Azri, can you see me?
Sure, Ken. You may start now, Dr. Imran.
Okay. A very good morning, ladies and gentlemen. My name is Dr. Muhammad Imran Sarwar, and I'm the Adjunct Associate Professor for DRB Highcom University, Malaysia. And I'm also co-founder and CTO for Digital Next Malaysia, as well as co-founder and chairman for Evolution IR 4.0. I'm really grateful to DRB Highcom University for giving me an opportunity to present to you today about Industry 4.0 landscape and skills for the post-COVID-19 era. So before we proceed with our webinar, let's look into the fourth industrial revolution, a quick glimpse. So the fourth industrial revolution is a journey, and that journey started from the first industrial revolution, which is happened in 1784 about mechanical production equipment with the advent of steam engine. So steam engine makes a mechanical landscape for industries across the world. Then the second industrial revolution started from electricity. The advent of electricity brings a landscape for mass production. The third industrial revolution comes up with the automated production line with the advent of networks and internet, starting from 1969. And the fourth industrial revolution, which is also called smart automation or digital automation, uses complex tasks and makes the factory or landscape autonomous with a minimum input from the human. So Industry 4.0 or Fourth Industrial Revolution have a different names around the world. For example, in Germany, they call it Industry 4.0. In UK, they call it Fourth Industrial Revolution. In China, they call it Made in China 2025. Japan, they call it Society 5.0. America, United States call Industrial Internet. And in Malaysia, we are called it Industry Forward. So different names synonymous, but moving toward the same compliance of smart automation. And using this automation, it is coming up across many factors and many sectors, including Smart Factory 4.0, Smart Agriculture 4.0, Smart Healthcare 4.0, Smart Logistic 4.0, Smart Construction, Smart City, and so on. So whatever sector using technological pillars of Fourth Industrial Revolution and compliance, it becomes Smart X 4.0. The Fourth Industrial Revolution or Industry 4.0 have technological pillars which are working together in an ecosystem that makes smart automation and smart factory, smart agriculture, everything to make it compliant for Industry 4.0. And the main and the first ground platform pillar for the Industry 4.0 is IoT, Internet of Things. So in case of a factory, the IoT devices can be machines, robots, PLC devices, sensors that are producing data. And for your information, the fuel for the fourth industrial revolution or Industry 4.0 is data. Without data, there is no revolution. So data plays an important role. In the last century, the factories are basically using a fuel or black water. Black water, which I mean is oil. But the factories of today, in the fourth industrial revolution, the data is the fuel of the industry, which is being produced by IoT devices and machines in the premise. Now this data will be transmitted towards cloud, which is the second pillar. That communication technology can be M2M, which is cellular, or any other technology, sending the data to the cloud, and cloud will save the data and make it accessible for anyone around the world. This stored data in the cloud basically used for analysis. When the data gets bigger, it becomes big data analytics. And in big data analytics, you will do analytics of past, present, and future, meaning predictive analytics at the end for the future, which dependent on the descriptive analytics of the past. So the past, present, and future will make it prediction of the event that can be occurred within the Industry 4.0 ecosystem. And that prediction using AI machine learning. So artificial intelligence is the fourth pillar of Industry 4.0, which leverage the machine learning where machines can be semi-autonomous or autonomous without interacting with the humans and perform their tasks intelligently. The other pillars which are important and mentioned in this slide are augmented reality, where the factory workers using AR glasses or mobile phone can able to learn about the health of a machine or can have the training as soon as possible. Additive manufacturing is another pillar, which is also known as 3D printing, is another important integral part. Cybersecurity, simulation, autonomous bots, advanced materials, and system integration are the rest of the pillar. And these pillars are increasing. And quite recently, there's a new pillar which is being included in the Industry 4.0 landscape, and that is called blockchain. Blockchain is used for traceability, end-to-end traceability. A factory itself is a part of supply chain, where it is communicating with asset management, warehousing, and logistic as well. So in blockchain, a user or any person can have a traceability feature at the end of the byproduct until the beginning where it was being produced. So enabling technologies and the digitalization of production-based industries are driven by these technological drivers or pillars. The top 12 Industry 4.0 use cases for the smart manufacturing are presented in this slide. You might wonder why Industry 4.0 is important, especially in this time where there is a lockdown because of pandemic called as COVID-19, which stranded all of our humans in the homes. And when we are at home, the factories are basically stop working. The supply chain becomes stagnant. And why it becomes stagnant? Because they are not smart. If they are smart, with the less interaction of human, they can be a remote manufacturing factory or any other factory. So Industry 4.0 compliance is very relevant from today onwards, because even if there are no workers, still those factories can be controlled, monitored remotely from anywhere around the world. And the important use case of the remote factories are, for example, predictive maintenance, monitoring, which is called remote monitoring, additive production, data-driven quality, advanced digital product ecosystem, augmented operation, and data-driven inventory optimization. Like I mentioned before, Industry 4.0 needs data, and using a data which has been produced by IoT machines, you can able to control and understand everything remotely. So it is very safe to say that this industry or future industry is data-driven industry. So we are moving from manual industry to data-driven industry ecosystem, which is basically autonomous and can be worked without much interaction of the humans. This is basically a traditional Industry 4.0 ecosystem, and when we apply different technological pillars, they are working in a harmony and in an autonomous environment. So IoT, Internet of Things, which you can see on your right side below, are basically objects, internet object-based communication devices, real-time data capturing. It is from different kind of machines, devices, robots, and they are sending the data from the production line towards the cloud. And when the data is being sent to the cloud and saved, so gradually with the passage of time, that data becomes bigger. The more bigger the data will be, the more better it will able to create a decision, autonomous decision. So machine learning AI needs a big data analytics for making a decision. Big data analytics are for visualization, for dashboard, for forecasting of the future or graphs of the past. But machine learning is basically a way to control machine autonomously, and they can able to work based on their past experience. And what is their past experience is basically in the form of data. So in a production line, there might be hundreds or thousands of machines working together, producing the data and sending the data to the cloud, which can be monitored by a supervisor anywhere around the world. And for example, for predictive maintenance, all of the machines are basically sending data. Let's say if the machine are not sending the data for Industry 3.0, and if one machine out of 100 machines stop in the production line, whole production line stops. And when the production line stops, this means that factory is not working. This means you are at loss. Every second you are losing hundreds of thousands of ringgit. To cope up with this situation, Industry 4.0 compliance factory have a predictive maintenance. They can predict which machine on which production floor may goes down after 1 hour. So you can take precautionary measures before that and save a lot of data, which is basically in the form of ROI. So in a smart manufacturing analytics platform, what you can able to see is this, that there are sensors, technologies, services, tools at the bottom, and they are dependent on the data, which this data, IoT data or sensor data, can be, for example, temperature, vibration, and pressure, etc. For production data, they can be utilization in terms of quality and setup time. Plant and supply KPIs can be OEE, on-time delivery, output volume, and risk factor might be downtime, bottlenecking, quality. All this data can be saved in the cloud. And for the analytics, statistical modeling, machine learning, simulation, and optimization plays an important role using those data. And what are the important use cases of smart factory? That, like I mentioned, predictive maintenance, which predict tools, defect, and machine downtime before they happen to take proactive maintenance action. Or real-time monitoring, where process and production sensor data in the real time from machine to the global reliability portal store in the cloud, and you can able to do and see the visualization anywhere. Predictive quality, which is increase the product quality and reduce the waste and cost by analyzing the sensor data in the production process. Similarly is basically process mining and location-based solutions. So Industry 4.0 itself help maintaining the factory, increasing the ROI, and any kind of disruption happen like pandemic, like COVID-19, still with any disruption, it will still able to run and the supply chain will not stop, helping the whole ecosystem. So in short, the summary for Industry 4.0 is that it has principles like interoperability, information transparency, and technical assistance, and it's decentralized decisions. This means that it is not centralized, and then it's a decentralized, making it quite easy, and there's no bottleneck. So the QoS, which is quality of service, is basically very fast. So 91% of the industrial company are investing in digital factories, especially after COVID-19. They realize that how important Industry 4.0 is. Their factories are closed, their ecosystem is closed, so they realize that using Industry 4.0, if the compliance environment is already installed, even there's a pandemic or not, even if there's a natural disaster or not, factory can still able to work. 72% of the billions is basically expected level of global spending on IoT solution by 2020, which is this year. And I see that after the MCO and the lockdown, although the production line and everything in the global economy getting slower, but when it come back, it will be quite much rapid. So in the pre-COVID context, before MCO and before pandemic, we were seeing that there's adoptability around the world, even include ASEAN and Malaysia. There was a national policy by every country, including Malaysia. And there were hundreds of seminars happening in Malaysia about Industry 4.0, about the advantages of Industry 4.0, the need of Industry 4.0. And Ministry of International Trade and Industry come up with a grant for SME to embrace Industry 4.0 in the form of matching grant like 50-50 or 70-30, because they realize that these SMEs are basically subcon for the MNC, and MNCs are basically moving forward and very fast. So if these SMEs are failed to deliver on time using the disruptive technologies, they might lose the business, and MNC might able to leave Malaysia and went to another country with a proper digital supply chain end to end. So the major Industry 4.0 national initiative in ASEAN basically happen in almost every country. For example, like in Indonesia, they launched about making Indonesia 4.0 roadmap in 2017. In Malaysia, the development of National Industry 4.0 policy framework was being presented in 2018. And there was an establishment of Industry 4.0 high-level task force in 2017. Goes back all the way for the National IoT Roadmap in 2015. And this roadmap was being launched on Menara Miti in October 2018. Similarly, Philippines, Singapore, Thailand, and Vietnam is also moving rapidly towards the Industry 4.0 ecosystem in their country. So what happened? Who is where among the 10 ASEAN countries, and where is Malaysia standing in terms of moving towards the readiness? The first is basically a roadmap, which has been created by the ministry and the policy maker. The second is basically a readiness assessment to assess whether the SMEs, particularly in automotive or manufacturing, where they stand. Do they stand in Industry 2.0, Industry 3.0, Industry 3.5, or they are already Industry 4.0. So in the 10 ASEAN countries, Singapore stands number 1 with a readiness score of 8.31. So the readiness drivers depend on national initiative and the implementation of the roadmap, specific initiative on disruptive technology. And these disruptive technologies starting from IoT, cloud, big data analytics, AI, robotics. Malaysia stands as number 2nd among the ASEAN in terms of driver of production and readiness score with 6.29. So as we can see that the e-government and the government initiative and policy making is basically compliance. Then there is a specific roadmap initiative basically roll out in the form of assessment by readiness auditor and specific initiative across different sectors. So initial mapping country readiness around the world. This graph basically shows about the readiness of the countries in East Asia and the Pacific, Eurasia, Europe, Latin America, Middle East and North Africa, North America, South Asia, and Sub-Saharan Africa. I'm delighted to share that Malaysia stands among the nations who are leading Industry 4.0 initiative across the region. As you can see, the scores are from 0 to 10, and Malaysia stands in terms of drivers of production rank as 22, structure of production rank as 20. Singapore is also over there, as well as Thailand. So these basically the drivers of production shows potential to adapt and adopt the 4th industrial revolution, consists of demand factor, technology and innovation, institutional framework, global trade and investment, human gap, sustainable resources, while structure of the production shows the existing factors on the ability for the 4th industrial revolution. Consists of scale, complexity, and production. The source is World Economic Forum. So this means that Malaysia is among the countries which are having a readiness assessment already. So what happened during the COVID-19? What we see across the world is a major job loss because industries were closed, people were being asked to stay at their home, and as a result, the offices, enterprise, organization, industries was being stopped. And when they was being stopped, the demand and the supply get disrupted. There was no generation of income. As a result, there was a massive job loss. This timeline of peak jobless claim is basically shown from 1970 to 2020. I don't wanted to go quite much far, but the last three, basically the jobless pandemic situation with the global lockdown and recession happens in number 1 in dot-com bust. If you remember in 2001, 9/11, 2 million jobs was lost only in US. And the second one was Great Recession in 2007, 8 and 9. But as you can see, in 2020, there's a major job loss, 22 million only in US. So you can imagine how much job loss will be happen around the world, especially in Malaysia, which is heavily relying on the labor force. Why they are relying on the labor force as an operator in the factory? Because their existing factory assessment shows they are either 2.5, either 3.0, or 3.5 or below, but not 4.0 mostly. So post-COVID-19 era, what are the impact and challenges? The impact of COVID-19 on the industry, short-term, there are short-term impact and there are long-term impact. When I mention about IoT end-to-end solutions define the smart factory, and it is basically compliance or first step towards Industry 4.0. So short-term and long-term based factors that impacting the industry due to COVID-19 are presented in this slide. The green are representing the positive effect. Red are representing the negative effects. And the gray is the effect which is neither positive or nor negative, meaning they are neutral. And the metrics for benchmarking in this case are basically effect on enterprise technology needs, effect on technology in general, effect on the technology itself, effect on specific applications of smart factory, effect on security and privacy of smart factory, and lastly and very importantly, effect on people and relationship. We know that after MCO is been lifted, maybe after 2 weeks or 1 month, God knows, there will be a social distancing norm. There will be a new order that needs to be compliant by every factory. And then social distancing will change the way we are working. It will change the way we are communicating, and it will change the way the businesses, the end-to-end supply chain will work. And definitely it has effect. So the government is trying its best to come up with a SOP, a procedure that can able to be followed by the factory workers as well as the business processes in those factories. Because there are news that by the end of this year, there might be second wave of COVID-19. The million-dollar question is, are we prepared for the second wave? And if we are not, what are the rapid steps that we need to take in order to avoid the situation that we are right now and not having a disruption of production floor, so our factory will able to work very properly. Now, let's discuss about what are the negative impact of COVID-19 on the industry during and after the COVID-19 era. The cost has to be reduced because the demand is reduced. So the CapEx will be reduced in the short term, but in the long term, after the MCO has been lifted, the lockdown is being lifted, the process became more automated. People, industry will start adopting Industry 4.0 compliance for their smart factory. And there's a term for that, which is called remote factory. So if your industry is basically Industry 4.0 compliance using the disruptive technologies of IoT, cloud, big data analytics, machine learning, cybersecurity, and so on, then you have a smart factory, and the smart factory is remote factory. And remote factory means you can able to process, control, monitor from anywhere around the world, and it will be running. In some of the cases, it is also called dark factory. Why it is called dark factory? Because it is so autonomous that you don't need a light in the production floor to work, because machines don't need a light. They have the cameras, very high intensity cameras, and they can able to work and process and automate the production floor and all of the process without having a light. So we are moving towards this direction. And there's a debate. The debate is that, oh, Industry 4.0 is excessively using AI machine learning. So this means our jobs will be gone. And I think from different angle, actually there are two schools of thought. One is Jack Ma school of thought and one is Elon Musk school of thought. Jack Ma school of thought says machines cannot replace humans because they are lacking creativity element and problem solving skills. They rely on the data of the past, and they will try to focus in one problem only, where humans can be multitask and they can able to focus on multiple domains for the problem solving. This is first school of thought of Jack Ma school of thought. The second school of thought, which is Elon Musk, they say that machine will replace humans. and they are giving a justification that everything can be smartly automated. Okay, what is my view on that? I'm a neutral, it depends actually. But what I see is this, that definitely the repetitive task, the task which is being repetition without any change will be gone to the machines. And they will be replaced human on those jobs. So what will happen to those people whose job has been replaced beforehand? They have to upskill or reskill their skills. The upskilling and reskilling is basically a part. For example, data scientists, data engineers, machine learning engineers, blockchain engineers, these jobs were not available 5 years ago. They didn't existed actually. But now the old jobs are basically gone and new jobs are coming. And the bottleneck right now is this adaptability. Are the universities and schools are fast enough to adopt those new environment? Are they making their ecosystem so fast they can able to match with the current pace of industry and digital transformation? The digital transformation itself is very fast. So whatever is relevant today might be obsolete tomorrow. So they are not that much fast because of either bureaucracy or others. So the students means the future workforce or the current workforce needs to know a way to upskill their skills at very fast pace. Moving on for these slides, in terms of we know the better business transparency is needed in the short term, and that transparency can only be happen if you have a smart factory, because you can able to see using the dashboard about the processes, you can monitor everything. But currently, if your manufacturing is not compliance, you cannot see the bottlenecks, you cannot see where are the process going and how much time and how much efficiency they are having. In terms of technology in general, short-term ongoing projects are stopped or paused because factories are not working, because the workers are not over there, heavily reliance on operators. In the job scope for those operators in the industry 4.0 needs to be upskilled for DevOps. So operators and the developers or IT merge together. So if you have a production floor and there are 1,000 people are working, most chances in the 5 years time, 90% will not be working on the production floor because everything will be automated. So 1,000 workers, instead they might be 100 workers, or in maybe in some cases 10 to 50 workers. So where those workers will go, we need to create a policy for upskilling for them so they can able to have a new jobs. Do you remember that 30 years ago there was no ATM? So if you want to have money, withdraw money, what you do? You basically wait for the banks to open, you go to the bank, and then you be in a long queue, wait for your turn, and then you verify yourself in front of the bank officer, and then you get the money. So it might take a couple of hours. But with the ATM, it was so convenient that you can able to withdraw money from anywhere around the world at any time. So what happened to the person who was in the bank who was giving you money? Basically, that person was upskilled to some other new job. Similarly, in the current factory environment, those operators which are doing the repetitive tasks, or those manpower which is doing repetitive tasks, which will be replaced sooner or later by the machines, basically will be upskilled. And why industry is moving in this direction? Because of accuracy. Accuracy in a way that the machines can have a very less chance of getting an error. Of course, machines also don't take leaves and they don't go for makan break also. They work 24 hours, so the productivity will increase. In terms of technology, ongoing projects are paused, declining demand for now because there is no supply. And the positive aspect that you can see is this, that some enterprise technologies are taking off to solve this problem. Many digitalization initiatives get accelerated or intensified. The digital divide widens in the company. The cut tax during the COVID-19 fall behind. This is basically a neutral aspect. The IoT networks largely unaffected, means that the communication of the telecommunication or Wi-Fi or any other network technology during the environment of a factory is unaffected. They are still working. So this means they are working. It's a leverage to upgrade your machine to IoT machine so you can able to connect with them and basically have a monitoring strategy, autonomous environment. Some of the technology roadmaps get delayed, which is in fact in terms of technology, and the effect on the specific application decrease interest in consumer IoT devices. Consumer side, it is decreasing, but on the industrial side, it is increasing. The remote asset access become important. It is so you can able to know about your supply chain. Digital twin will help in this scenario for planning. New use cases for drone are coming. So if you wanted to have a security, for example, for the factory, drone can able to help you in this regard. What is the most important aspect in terms of cybersecurity? Because factories are closed or semi-closed, so there is a high chances of cybersecurity attack on those factories. Hackers are basically strategizing a change, and from what my knowledge is, in Europe and in other parts, there was quite much cybersecurity attack on the factory which are basically not working. It is still connected, they're still on, but there is a high chances that your servers or your machine can be hacked. In the next slide is basically on impact, which basically what I feel needs to be discussed in terms of weeks, months, and next year and next decade in terms of planning. The previous one and this one. This one is basically, I will touch on the lower part, which is on the people and relationship. Job loss is happening quite much fast. Vendors are not providing free product and service. So there's a skill shortage. And this skill shortage can be filled by massive and rapid upskilling program like can be done by DRB, HICOM universities, USM or other basically institutions that can able to come up with a program, or I think they already have a program that can be tailored for the need of specific environment. So if you are thinking that upskilling is not important, it is, because without upskilling, you cannot have a roadmap implementation of your factory to become a smart factory. So the upskilling of IoT engineers, big data, cloud, blockchain, AI, machine learning is a necessity, because these are the core technologies which have to be used in every sector, not only in manufacturing or factory, but also in agriculture, also in fintech and other things. So global impact. What is the impact right now? What was the projection of the economy versus pre and post analysis is being presented in this slide. So before COVID-19, you can see in 2017, 18, and 2019, there is a massive growth. So you can see that the market size in terms of US dollars, in terms of billions, are increasing. So that was the main projection. Okay, but the post projection for COVID-19 is represented in terms of dotted line. So in 2020, there is a decline in the global economy, especially in terms of smart manufacturing market. But instead of basically, if we will be moving rapidly towards the digital transformation of our factory, having an Industry 4.0 compliance, then there is a chance that there will be a gradual increase over the course of coming years. So for the factory workers, for COVID-19 occupational risk, the green and blue are two metrics. Okay, the green is basically healthcare related and blue are industry related. Even though that the industry related risks are less, but because of environment on the production floor or in the factory and offices, if they are not having an SOP and compliance of social distancing, this graph will change. So if you have a social distancing applied as a part of SOP in your respective organization, then there are high likely chances that your manpower will basically get affected. So before we have a compliance on smart factory, it will be important for us to understand the new norm after the post-COVID era. And in the post-COVID era, the way the whole supply chain will be different. I'll give you one problem. I'll give you some understanding of one problem that you can able to understand. Let's say the factory workers every day in the morning are going towards the factory in one bus. So bus package might have 20 workers inside. Now in that term, for the social distancing, it is basically having a procedure that there should be one person sitting in one row in the bus. So if let's say there are 20 passengers in a bus in a pre-COVID environment, in the post-COVID environment, there might be 8 persons sitting on a bus having a social distance application. So it will able to change the dynamics. It will increase the cost, number one. Number two, it needs to have a proper way to solve this problem. So this is just going towards the industry. How about inside the manufacturing plant? What will be the social norm for the operators and the people working together? They must need to have a 2 meter or 3 meter minimum distance. Let's say 2 meter, and then proper basically mask, proper clothes, and proper procedures for them to look into. Another example or challenge is this that in most of the places they are not encouraging to open a toilet in the office or organization. So what will happen in the factory environment in the post-COVID era? So these things needs to be considered when we are basically going towards new order, or should I say, in some people are saying new world order. I'm not sure about that. So the important lessons that we need to consider, keeping our mind in terms of digital supply chain or normal or traditional supply chain, is this that lesson number one, inventory level we need to consider has to be digital. So you can able to locate, understand, and basically know and monitor your inventory, because inventory level are basically the first thing that needs to be considered as a digital. Number two, making facilities more conducive to physical distancing. Like I mentioned about the work environment, the cafeterias, the toilets, the meeting rooms, the way the procedure is happening, everything needs to be revised. So during the MCO time, let's say this coming month in May, there's 1 month for us to understand the problem and come up with the SOP based on our different kind of environment, different kind of industry. There might be similar SOP across the board, and they might be different in some cases with the different sectors. So physical distancing will be encouraged, because if one person get affected, whole factory will be affected, and again that factory will be closed, and there is a high chances that it will able to close until further notice. So our goal will be that we will able to make the factory working without any even stop. And the fuel right now are basically humans. So we need to take care of humans. And the ideal scenario is factory workers means humans, and the robots or machines are working together in a collaborative way. This is our goal for the Industry 4.0. Number three, third lesson is alternative supply in case of different geographies. Let's say for the materials of our supply chain of our product, if they're coming from one country and it has to have a problem, then you need to have an alternative or backup plan to have multiple suppliers from different geographical locations, so there is no disruption happening for the suppliers of the materials or other things. Third important lesson is basically remote monitoring. So when we talk about remote monitoring, is basically we can monitor remotely not only humans but also the process, which I mentioned earlier about the predictive maintenance. Next is basically update your risk and guideline to work in a factory and industry. You have to come up with a new factory SOP. You have to identify the risk, and you have to not only come up with the proper guideline, but also deliver those guidelines to your workforce, so at least they can follow those procedures and guidelines in order to do work. And lastly, basically connected workers. So connected workers basically give not only them but also you the leverage to understand not only their work performance but also their health, because without health there is no work. So industry recovery plan for COVID-19 era. What should be the industry recovery plan? Number first, please move towards the compliance. Have a readiness assessment. The first step is basically readiness assessment. So you have to assess your readiness. And once you assess your readiness, you have to have a strategy. You have to identify your business challenges versus opportunities. And who can do that? Basically, the higher management, the decision makers in the organization can do and come up with a strategy. And you yourself cannot do alone. You have to engage some technical expert or consultant like us. So we can assist you in that roadmap by understanding what are your process, what are your pain points, what are your challenges and opportunities, and how you can able to basically follow and equip yourself. So it's basically roadmap implementation. So after the definition of strategy, the next will be the opportunity, how business meet technology, how you can leverage the IoT, cloud, big data analytics, machine learning, cybersecurity, additive manufacturing in your current environment. What are the policy you wanted to make? Of course, you don't want to have a heavy investment. So what will be the way? If you don't have a IoT based devices or machine, you cannot replace them overnight. So you can upgrade them. So there are consultants available like us that can assist you by coming up with an embedded system that can be attached with a device and enable them for IoT enabled device. So at least the data can be generated and transferred towards the cloud. So machine monitoring and predictive maintenance can be happen. Then next is to start small. You think big, but start small. Start small means have a pilot, have a prototype. So this proof of concept will make you understand what will be achieved by your factory and what will be the advantages you will be getting and how much ROI will be calculated based on the effort. So pilot project, you will learn new thing because you are evaluating and reviewing, and then based on some of the feedback, you will adapt, execute, and meet that strategy. So it's basically like a wheel. So you will come improve your strategy, have an opportunity, pilot, learn, adapt, and it will be go on until there will be a time that your factory is mature enough and reach to factory 4.0. Second step is, what is the industry 4.0 roadmap implementation? So there are 5 levels. Like I mentioned, during the passage of time, when you are having a prototyping, you are basically upgrading yourself from level to level. So the first level is basically stovepipe, which is organizational and operational silos. People are working in every organization, or most of the organizations, should I say, which are not compliant with the industry 4.0 or digital transformation. They are working in silos. So we need to break those silos. We need to cancel the sea of competition and bring a new sea of collaboration. A collaborative environment is basically necessary in this era of digital transformation. You have a manual and non-standard process that needs to be upgraded. So explore an IoT opportunities and focus on the data governance and information sharing across the critical and high value process. Once you do that, you have a collaboration by exception. You have a connected data and devices, IoT devices in level 2. So you're breaking the silos. You are transforming your organization in terms of collaborative environment. So it's a culture. Culture in terms of people and process. So for process, you will able to upgrade your machines to IoT machines. They have a connectivity. You get data from the devices, share data upstream and downstream, and pocket of the process level in the form of dashboard analytics. So connectivity, disparate data resources and operation system to enable a cross-functional collaboration and visibility will take place. You will see that in level 2. Level 3 is integrated enterprise. You have a collaborative planning, standardized ERP suite, consolidated business intelligence and data warehouse, and vendor information sharing. And what you will achieve? It will make your integrated data with the operations to automate process. So firstly, it will be semi-automated, and then it will be moved towards maturity and become fully automated. It will have an optimized performance and improve decision-making agility. It will not happen overnight, but it will take a couple of months. The level 4 will be integrated value chain. So when we talk about value chain, it has a predictive analytics you already achieved. You have a process automation, formation of digital thread, and you will be focused on the third-party system integration and end-to-end visibility. You would like to have an end-to-end visibility from logistic, data warehousing, smart factory, again logistic, and towards the end consumer. And the level 5 is basically adaptable ecosystem. You created an ecosystem with the data monetization, intercompany planning and collaboration is there, end-to-end process management will be there. And then we are going towards prescriptive analytics, which is the fourth form. So in the big data analytics, the first is descriptive analytics, which is data of the past. Then diagnostic analytics, which is why those things are happening. You identify the problem. Then predictive analytics, which is talking about future. You are predicting maybe one thing or multiple things. And the fourth level is prescriptive analytics, means from those solutions, which one is the most suitable solution that you should be using for your process. So this is a high level roadmap, Industry 4.0 technologies that you will be using, adapting, adopting, in moving towards a journey of digital transformation. And why I have used a word journey, because it will take passage of time to adapt and having a compliance for Industry 4.0. Like I mentioned, think big, but you have to start small. You cannot afford to start big because at the end you will lost quite much of time and revenue. So start small and gradually using incremental approach, you will able to add different departments, and from different departments, you will come up with the different factories towards a supply chain. What about the skills? You have the assessment, you have the roadmap. The next level is basically skill development, which is basically technical and soft skill. So when we talk about technical, we have a pyramid. We have a technician in the level 1, we have a specialist in level 2, and we have an integrator in level 3. So every pillar like IoT, big data, or machine learning, or cybersecurity, you must need to go for this first level, which is fundamentals, then advanced, and then basically on the expert level. And like I mentioned, the new jobs are coming, all jobs are going. So Industry 4.0 integrator, IoT engineers, in the yellow, if you can see, IoT engineer, data scientist, data engineer, machine learning scientist, BI engineer, analytics manager, DevOps engineer are the new jobs which are coming and which are already here. And they are highly paid jobs, so you can upskill. So when you are thinking that, okay, I am not from IT or engineering background, can I able to adopt? Yes. Programming is basically necessary right now, and using Python programming language, you can able to have a skill of programming with very short minimum span of time. Like normally, based on my humble experience, for a person who never did programming before, can have a basic programming understanding and applicability within 2 to 3 weeks. So Python is easy to learn and easy to apply. And why I encourage Python? Because Python programming language, open source, this means you don't need to pay anything. Number two, there is a very good amount of tutorials and the community available on the internet. Number three, which is the most important one, is this that Python programming language can be applied in any of the industry 4.0 pillars. Meaning that if you learn Python programming, the baseline, then you can use specialized framework and libraries for IoT to develop an IoT solution. You can develop a cloud and DevOps solutions. You can develop blockchain solution, big data analytics solution, cybersecurity, machine learning, anything using that language. So it's like fundamentals if you have, then the next step is specialization or advancement. So in that case, you will be having a pillar or technological aspect related libraries that you can apply to develop a solution on that specific pillar. So technological skills are necessary, but you have to understand that in the path of digital transformation, these technologies will evolve. There's an evolution. So what is basically required for you, which I think is a mandatory one, is the soft skills, because the soft skills will help you in the long run. So apart from technical skills, you must need to think about soft skills. So the technical skills are basically job specific skills, but personal skills, thinking skills are basically important for you. So job specific and digital skills are basically these IoT, big data, AI, and the thinking and personal skills are basically like critical thinking, problem solving, decision making, and so on. And you need to have a digital element on that because industry needs a person who is effective, critical thinker, problem solver. The programming and all these libraries and technology are basically merely a tool to solve a problem. So if you have a problem solving skill, critical and creative skill, decision making skill, the chances is that you can learn all these technology skills very fast. So emphasize on both. Emphasize on both aspects, which is technical and soft skill. And if I go deeper, emphasize on your thinking skills, your digital skills, your job specific skills, and your personal skills. So these are basically quite mandatory because when you have a collaborative environment with the robots or machine in the industry 4.0, then definitely these skills will definitely help you. What will be the advanced certification that you can look into? Basically IoT based, big data analytics based, artificial intelligence based, cybersecurity based, system integration based, augmented reality based, and blockchain based. And there will be few or many of these webinars or training will be coming on the way for the upskilling. So when you have assessment, strategy, roadmap, technologies, and skills, then you create an ecosystem of Industry 4.0 compliance, which is Factory 4.0, which had Human 4.0, Process 4.0, and the Environment 4.0. So that is basically a conclusion for basically the webinar session for this. So in short, if I wrap up my session for the things that we discussed just today, Industry 4.0 is not a myth. It is being applied around the world, and the factory, especially latest news is that Germany is the fourth most affected COVID-19 country in the world. And with so much death, they have a smart factory and they already start opening it and it is start working it. I was reading that the Volkswagen factory and other automotive factory are already in the production running and the factory and supply chain start working already since last week. So how they can able to have such a fast formation is basically through the digital transformation and having an Industry 4.0 compliance. So if we wanted to move forward, maybe the government is doing very hard work on policy making in grant. And of course, universities or other training providers are providing HRDF compliance webinar or trainings, but that is not enough. The main thing is the decision makers has to realize that if they don't move towards Industry 4.0, then in the future pandemic, which might occur maybe this year or whenever, their factory will again stop, they will have losses, and then there will be production loss, there will be job loss, and there will be business loss affecting the economy of a country. So if you would like to avoid this kind of a situation, pandemic COVID-19 came here to teach us that with the digital transformation and Industry 4.0, it is a reality that we can have a remote factory that will not be disrupted, that will not be stopped because of any pandemic or natural disaster situation. So with that, I will end and conclude my webinar. Over to you, Dr. Azri.
Thank you very much, Dr. Imran. Very fruitful discussions. Okay, our next session will be the live event Q&A session. So I will go through each question postulated from the participant from this chat session. So we will go through the first questions, Doctor. Okay, from the SJ. How to encourage the SMEs to embark in RR 4.0 since for them is high investment and risk on ROI?
Very good question and very relevant question, and this question is being asked by many SME CEOs to me when I am in the conferences or in the talks. You have to realize that the government of Malaysia, MITI and MIDA are giving a grant. So they were having, they would like to select 500 SMEs in which they can able to help them on digital transformation of their factory. So the focus was on two categories. One was manufacturing, and second requirement was basically either manufacturing or manufacturing services. So two sectors. So when you have this thing, then definitely you will be having a grant, and you can able to go to MITI and MIDA website to have clear understanding of what are the requirements of the grant and what matching grant they are giving. They are giving by 50-50 matching grant or 70-30. So if you are qualified, then the readiness assessor will basically come and visit your factory and understand where do you stand first. Okay, if you are in 3.0, it's basically 3.5. This is the assessment. They will look into your process, business model, your skill development and everything. And then they will come up with the roadmap implementation, that what steps you need to take to move towards this direction. So the grants are available for that. But the question arises, in Malaysia, there are thousands of SMEs, and maybe some of the SMEs doesn't comply with the requirement for those kind of a grant. So my suggestion will be that you think big. I think you already think big, because if you didn't, you might not be attending this webinar. This means you are serious enough to understand how you can able to move towards Industry 4.0. But you have to start small. And that starting small doesn't require much of the investment. It just requires three things: a clear understanding, number one. Number two, having a business need and problem that you have identified and what you want to achieve to get long-term ROI. And number three is basically upskilling of your existing workforce. Okay. Now, when you are looking into Industry 4.0 compliance environment, the base platform is data, and the data will be produced by IoT devices and machines. And if you have a legacy machines, definitely one machine might cost you hundreds of thousands, in some cases maybe millions. and in production environment, you might have hundreds of machines. So the question is how you can able to replace all those machines. So the answer of this question will be you engage consultant like us, and we will able to have a special enhancement, a device, embedded device that can be attached in with your legacy machine. It can get the data from VGA port or from other sources, convert those data into a readable form, and it will have an ability to communicate with the edge gateway or cloud. So the definition of IoT is three-factor. Number one, any device that can connect with the internet. Number one, connect with the internet. Number one. Number two, send data and receive data. This is the second. And number three, real time. Real time is an important factor. So if the device is sending a data to the cloud now, it has to receive the data result now. Cannot be after 1 minute, cannot be after 5 minutes, 1 hour, no. So IoT devices has to be real time. Like for predictive maintenance, when the machine temperature is being increasing gradually, so it has to be sent to the cloud now. So machine learning algorithm can able to predict, okay, this machine will able to goes down or reach the threshold amount of the temperature value after half an hour or after 5 minutes. So if it get late, then the machine will burn. So the first step is basically for the implementation, make your devices IoT enabled. Second is start collecting the data. So you can able to choose one device or two devices first. Let's say 2 to 3 devices, and then there are consultants that will upgrade those devices with the minimum cost. You don't have to pay a million or 100 or 1,000 ringgit, maybe quite less than that. And then using those 3 devices, you start sending the data to the cloud and save the data first. Understand the data first. So the data scientists or data engineers will able to clean the data for you. And after the cleaning, they will be using machine learning algorithm. So you can able to have a predictive maintenance kind of a prototype. So the easier way first will be monitoring. Once you are sending a data to the cloud, your dashboard can able to pop up the information about your machine health. So you can able to know the status of your machine. You can able to know the other parameter of the machine. So the monitoring case is being done. Very good. So next step after monitoring will be predictive maintenance. So you can predict when your machine will goes down. So you have to start from the production floor and then gradually increase to the other department. So what you need to minimum have 3 machines that can send data. Minimum 3 to 5 machines is the optimal and recommended. Number 2, you need to have a cloud. And if you don't want it to have a cloud, it's okay. You can have a server. Initially, you can have a server that can collect the data. And then the next thing you need is basically analytical tools. Like you can use Apache Hadoop, Apache Spark using Python. You don't need to buy things. They are basically having their open source. So you can leverage those things. Of course, with this one server, you might need to have multiple VM to make it work effectively. So this is initial investment that you need to do. With this small investment, your ROI will be quite big. And as you can see, ROI is not only having less humans. Yeah, ROI is basically saving the time, increasing the optimization, and save from the pandemic like this, which we are facing now. So your factory will not be stop working. So in short, using small prototyping will make you understand how your ecosystem works, and you can have incremental approach. It might take 6 months, 1 year, or sometimes this journey might take 3 years, but still it's better to start small rather than not starting at all.
Okay, thank you very much, Dr. Imran. Okay, the next questions from DSJ. What is the layman understanding of blockchain and how it related to the cryptocurrency?
Okay, blockchain, there's a notion or myth. Notion is this, that blockchain is basically cryptocurrency. Actually, there are thousands of use cases of blockchain, and one use case is cryptocurrency. So in our factory environment or supply chain environment, what is the working of blockchain? It's very simple. Blockchain will allow the data to be saved in multiple places, so the integrity of the data will not be compromised. So the data is basically, as you know, it has a proof of work that require multiple servers that you don't know, and the data will be saved. So they are public blockchain. They can be a private blockchain also. So among the organization, if you have multiple factory, you can host blockchain server into multiple factories. So the use case for the blockchain in the smart factory environment is basically traceability. You can trace any information among the whole supply chain, like that specific part, like for example, at the end of the production line and at the end of the supply chain, if you scan a barcode of a product, then in your mobile app, you can able to have a traceability. Okay, the materials come from, let's say, China. It was left China by this company, by this logistic company. It traveled from, let's say, from Chengdu to Penang. This time, this person was received it. So logistic information will be breakdown, plus what time it was been manufactured, which place, who was the supervisor on duty, and how much time it will take on the production line, and then towards logistic again, warehouse, everything. You can able to have a end-to-end traceability in the supply chain, and that data will be transparent and having an integrity. If somebody wanted to change into the database, cannot, because the duplication of the data is basically across multiple servers, which you might not know. So blockchain is getting popular because of the data integrity case, in not only in manufacturing and automotive, but also in the healthcare, in the agriculture, in the fintech, in short, in every sector, and it is catching very fast.
Okay, thank you, Dr. Imran. So our next question would be from IR Fauzi. He asked that data saved in cloud will be accessible by all. Does it mean everything saved in the cloud is not protected under Secrecy Act or intellectual property?
When I mentioned about the cloud have three types. One is public cloud, which can be accessed by anyone. One can be a private cloud, which can be accessed only by the organization which owns it. And one is a hybrid cloud. So usually in the manufacturing on factory, they usually have the data on premise, means that private cloud, they have the data centers, okay, or they have the servers that are like a cloud. So in that case, they are basically having a data protection. Even they can use a hybrid one, means collective, some of the data that they wanted to be exposed or broadcast to the customers, they can able to have that hosted data in some AWS and Azure or any other cloud, or they can able to have the same other data in the premise account. So when we are having a cloud, we have to understand that it has a security algorithms, encryptions that make it basically a secure. I give you some example. If we are using a Facebook, everyone I think is using it. So in your mobile app, when you enter your username and password, it is saved as a token that is authenticated on the server. So it's a token or two-factor authentication. In the same way, when the IoT devices or machines are sending a data directly to the cloud or through edge computing gateway, they have a security protective layer, which can be TLS or basically other type of security algorithm. So the security part can be communication security, which is secured by a tunnel or security algorithm using cryptography. The cryptography can be symmetric or asymmetric. And if you wanted to check whether the data is being compromised or not between end to end or between the IoT device to the cloud, you can also use hash functions to check the data integrity. Now, the storage of the data in the cloud have its own security, and these security are basically compliance with the current standard. As you know, hackers are basically hacking every day. So there's a forces of good and evil. So every day there's a security patches coming that are basically increasing the security of the servers, which basically reduce the DDoS attack or hacking attack or other things. So cloud itself is basically secure. When you talk about vendor-based cloud like Oracle, like Amazon Web Service, Microsoft Azure, Google, Alibaba, they are basically very protective. They are having a lot of good security because they don't want that data should be compromised. But let's say because of the policy, because in some countries they don't want to use those platforms or cloud platform vendors because of national policy. In the Malaysia, you can have like TM have their own data centers. Exabyte have their own data centers. You can leverage TM data center, and the TM data centers are basically quite secure also because they are basically working on patches. They might be hosted on Linux environment or Windows environment, but they might be a regular patch. So please, there are two aspects to look into. One is basically security, another one is basically privacy. So definitely security, it is secure that I can able to assure, because if it is not secure, your Gmail, your Facebook, everything is not secure. But the question here, the million-dollar question is privacy. So if you are having a data hosted in Azure cloud, a public cloud or other, is it basically having a confidentiality? May or may not be. So my suggestion will be, instead of using those vendors, you can use local vendors like TM. And if you have money enough, good money to maintain your own data center on premise, then you can able to have hired those team and the servers that are on premise. But it involves a lot of cost, and that cost basically will increase gradual time. I'll give you an example. If you wanted to have in on-premise private cloud, you must need to purchase server, number one. Number two, license of the operating system and the tools. And number three is basically a manpower to manage them. So the initial cost is quite high, maybe 100,000, 200 or 300. Depends how many servers you are buying. But on contrary, if you go for the vendor specific, you need to have a VM, and that VM might cost, one VM might cost you about 500 ringgit to 1000 ringgit. And you might need 10 VMs or 10 machines, which is 10 less than 5,000 ringgit per month. So the initial cost 5,000 ringgit versus 100,000 ringgit is basically quite different. So it depends on your strategy. Usually in the SME, the CTO, Chief Technology Officer, or Head of Technology is responsible for those kind of decision making and the roadmap implementation.
Okay, thank you, Doctor. Okay, so we got a few questions here. Maybe we can quickly go through all the questions. Okay, the next question will be from Arif Izzuddin. He said that most factories today are stopped working because there are no automation. How about supply chain elements such as logistics and transportation, which is hard to be automated by current technology?
Okay, very good question. My favorite topic is supply chain and smart factory. Smart factory and supply chain. So supply chain, you are saying that it might be disrupted as well. Maybe true, maybe not. I'll give you an example. MCO in Malaysia, they allowed the logistic to go. So even the factories are closed, but the logistic people are going. Okay, so this is basically non-industry 4.0 compliance supply chain, right? But 2 years back, there are a lot of prototype happen across US and Europe, even in China. I'll give you an example of US. They have a logistic truck, autonomous logistic truck that travel from San Jose, California to all the way to Florida. So autonomous truck basically went from San Jose, from the west coast to the east coast of Malaysia autonomously. But of course, it was from highway only, not inside the city. So the technologies are improving, but the policy is important. Like in the current scenario of Malaysia, even if there is no autonomous truck, still your warehouse can able to have a logistic to send the things because government allows the logistics. We are going towards this path, and you will see Tesla and other companies are basically coming up with the autonomous truck, Tesla especially, and there are some Chinese companies who are also working. So within 2-3 years, you will see mass production of those trucks also, and it become affordable for the companies to have it.
Okay, thank you, Doctor. Okay, the next question would be, who are the most company which already successfully adopted Industry 4.0 technology in Malaysia? And you may also answer, do you know any top IoT player in Malaysia, Asia, or world?
Okay, I don't want to do publicity of the company who have adopted here, okay, but I can able to tell you that which are on the path of becoming digital transformation, okay, based on my knowledge, some local player and some foreign player that I can mention here. ABB is a foreign player. Robert Bosch is another player. So German-based companies are mostly already Industry 4.0. Even if they have the plant over here, they are semi or fully compliant, especially in Penang. Okay, and the local companies, if you are referring to construction sector, IBS system, construction 4.0 IBS system is been have by Gamuda. For the smart factory, I think Vitrox and Inari are on the way. For agriculture, Sandari are on the way there.
Okay, Doctor. Okay, this is questions from participants. What is the average earning for data engineer? And also, where are those advanced certification offered?
Okay, there are two questions. I will basically answer the second one first. Where
Okay.
are those advanced certification happening? DRB HICOM will be one of them, of course. USM, UScience, you can contact us. So they are data science, data engineer, machine learning. There might be many players who are basically teaching, but mostly introductory until middle level, not advanced level. So when you talk about data scientist certification, there might be public program, there might be specialized in-house program. So usually public program, the participant cannot able to bring their own data because of the compliance, confidentiality, and privacy. That's why mostly the data science program, middle one and advanced one are specialized and in-house. So this is your first question. So there are many players, including us. You can contact us. Okay, I myself is basically doing the data scientist, data engineering, IoT engineering training as well as blockchain. Coming back to your first question, how much is the earning? I have the figure. I think I will put that slide in my presentation, which DRB HICOM University can able to send you an email. The average salary in Malaysia for the data scientist is above 10K, from 10K to 20K. Normally in KL, you will find if you are good in good data scientist with experience, you will get above 14K. For data engineers are basically from 9 to 14K and even more. You can check more on the salary of others in Hourglass and Job Street survey. And not only the data scientist and data engineer jobs are available in Malaysia, there is a high demand everywhere around the world. And I can predict one thing, which I'm sure, because all of the SMEs and MNCs are on the path of digital transformation. This means they will be upskilling or hiring data engineers and data scientists a lot. So what are the path for that? I think certification might be of 1 month plus. If it is not 1 month plus for the data scientist, then I believe that it will be incomplete. And it has to have a multiple use cases. So
Okay.
you can contact us.
Okay, thank you, Doctor. Okay, another questions from IR Fauzi. In Industry 4.0 ecosystem, in a factory, for example, does it possible for the customer to monitor their order, starting material ordering, WIP, pre-delivery, so customer able to monitor time to market starting from after they're making an order?
Yes, of course, definitely. Not only the supervisors and the workers of the factory can able to monitor, but also customer. But it is depend on the business model the factory is having, and using that you can able to have a not only traceability using blockchain, but also monitoring of your process. Let's say it's an automotive car. You can able to know if any product, you will able to know about when was the military, when was it was manufacturing, when it was been packed and deliver, go for the dismantling and go for the logistic, and then at the end, what time. The important thing over here is not only the monitoring. The important thing over here is a predictive time. So accuracy of the time will be important element for the customer to view. Okay, my product will be delivered in 1 week based on the predictability, and it match with the supply chain as well. So if the accuracy is basically good, then it will able to have more effective meaning.
Okay, thank you, Doctor. Okay, another one questions. Okay, previously I'm using Python to run a simple defects recognition algorithm, but most of the people not recognizing the open source platform due to the risk of the availability in future. Yes, I agree that Python can do wonders to automate the data and process. How do we manage this risk to avoid any trouble in future?
Definitely, when you look into programming languages and risk, I think there's no risk of using Python. At the end, what you need to consider is this: once you learn different platform, what is the takeaway? There is a pros and cons of every platform. So Python might be very good in having a learning and applicability, and then reducing the cost of development because it will take less time, because programmer has to code less as compared to other technologies. So the time to develop a solution is shorter as compared to other technology. The real thing over there that you need to consider is performance. Which tools, which library, which framework you need to use basically to have a more optimized performance. I give you an example for predictive maintenance again. If you have a huge data set and if you have a lot of machines, IoT compliance means the QoS, the quality of service, should be high, meaning the jitter, the packet loss, packet delay, end-to-end delivery should be minimum as possible. And the data transmission, cloud processing, and then coming back to give result is end-to-end. So it has to be fast. So the performance metrics needs to be considered when you are applying. So for those who doesn't know the skills of the data scientists or big data analytics or machine learning, it is easier for them to learn Python and understand the ecosystem. And in the future, if you don't want to use Python and you wanted to shift to another, then there is no problem for that. So Python, why I advocate, is basically to jump into bandwagon of technology and have a prototype. So once your prototype is ready, if you don't want it to follow with don't want to use Python but another technology, you can use. And mostly the database that you will be using are the SQL based or NoSQL based. You should be using cross-platform. So no matter which technology you are using, you don't need to change much of the code. If you are using containers like Docker in the cloud and you are using Apache Spark or Apache Hadoop, which is open source and cross-platform, you don't need to change the code. And the machine learning algorithm can be written as a wrapper. So in the wrapper, you can able to change programming language. It will not affect. So it will act as a black box.
Okay, Doctor. Okay, this will be the last question to end the session. Okay, then maybe Doctor can conclude the whole discussions. So the question is, everyone knows that the most of developed country is implementing to IR 4.0, but most of industry in Malaysia is still within IR 2 and IR 3. How do we start? Is there any checklist, step, guideline for us to follow as guidance?
I am really grateful to the person who basically raised this question, and which is very important question. There are good news and there is a bad news. The good news is this, that if you are basically would like to move forward for that, there are a lot of government incentives. Government incentives to help you, assist you to move towards the path. The bad news is this, that they are very less consultant that can able to help you to in your journey of digital transformation, industry 4.0. So you need to choose your consultant wisely. There are many people who claim that they are basically done quite a lot of work, but maybe not. The foreign players, like the companies or technical consultants who are from abroad, they are charging quite much high money for organization to be consultant for the digital transformation. So what you need to do is you need to contact us, and then we can able to assist you in your direction. I think there will be a training in the future also, Industry 4.0 roadmap implementation. In that training or talk, there will be identification of the step-by-step approach and the checklist that you must need to have. They cannot be generic checklist, because every organization might be different, having a different business model in different sectors. There might be few points in the checklist which might be generic, but majority of the checklist might be different based on the different business model, different sectors, different environment, different processes, and other things. So to answer your question, you can contact us, okay, and then we can able to assist you in your path of digital transformation as rapid as possible. And you have to think one thing, you have to think big, but you have to start small so the investment will be less. So start small means you will have a step-by-step approach, step-by-step incremental approach, by having some machines with a server and with the output in the form of the dashboard, in the form of improved process, in terms of autonomous process that you can able to witness and see from your eyes, and you can visualize when you will expand them, how much it will increase your optimization, increase your ROI, and minimize your waste. Okay.
Okay, thank you very much, Dr. Imran, for the great presentation and for answering all the participant questions. So we hope that this session will be beneficial to everyone. For further in-depth discussion, we will organize other sessions for you to participate, and we will keep you posted. So for any inquiry, please do contact us at the RB Highcom University of Automotive Malaysia, that the email that we stated in the poster, the event poster. So I wish you all thank you, and Assalamualaikum warahmatullahi wabarakatuh.